As I said, today we continue on into Rust. So this is the second half of the Intro to Rust lecture. And before we begin, because it's been a while, right? The last lecture we did a recap on what can appear on your midterm, and then we talk about the projects, and then we have the exam. So it's been more than a week. So let's actually do a recap on what we covered so far, right? So we talk about type safeties in Rust, and we established that Rust is basically it's not we established, but I just give it to you that Rust is a well-defined as long as you have a well-defined program in Rust, you're not going to run into like some random undefined behavior, and it's a type-safe language where every program is well-defined, right? So with this, you can establish the truth or the fact that if you write a program in Rust, it's gonna unless you declare unsafe code, which you can do in Rust, it's gonna have no random undefined behavior on all cases of your program. And we talk about, okay, C type safe, can we actually do something that convert one type to another implicitly, and that's possible in C. Like you can actually use an integer as a floating point if you want to. The compiler would yell at you through the warning. It's like, hey, that's not safe to do, but you can use it, right? There's many kind of like small hacks you can do. You can declare your own struct in certain way, and that struct would be used as like bit pattern. So you can also do that in C. In Rust, is not the case. And the reason why I want to introduce Rust, actually, this is from the whole science division, right? Basically, it's a great language in terms of performance, right? Because when you look at, okay, you will look kind of grim, but if you look at modern day program, especially whatever get developed in Thailand, right? You're not gonna see a lot of high performance thing that come as a product. It can be unreliable sometimes because the performance is so bad that it crash, right? For example, the Malprom system, which can only handle 20,000 transactions per second, which is like abysmally low, right? Or the fact that sometimes like anyone heard the news that Baotang app crashed again when the new program came out and people have to enroll through that program, that app? I think it was last week. The Kola Kring phase 3. Yeah, these are kind of like the example that I can keep telling that if you don't care about performance, if you don't care about the true backend, right? The by backend I really mean the system. I'm not talking about those like full stack web development. Those are front end for us. If you don't care about the true like system software, this is what you're gonna end up with, right? Software that crash whenever there's a lot of demand, software that are so poor on performance, and you are not even gonna be able to tell how to improve it. In the end of the day, what I want you to know is, when you compile a program, right? The way it's actually being run on the hardware is actually eventually it turns into assembly. Okay, so computer execute things on the assembly code, and the language that you are using is a tool. Think of language as a tool to translate the algorithm, the math algorithm that you want to run on a computer, right? You can think of it in a high level computer, it's just a huge ass like calculator. It's capable of doing add, multiply, subtract, and or logical operations. And with that assumption, right, you can write fancy functions that do a lot of really, really great things, right? But at the end of the day, the language that you've been using are basically to translate your math algorithm. Well, the algorithm plus the math part, right, into assembly code so that it can run on a computer. So that's why the language, each of the language come with a trade-off, right? If you program in Python before, you would then realize that if you run complex program in Python, it would take more time. It would take more time than say running it in Java. it would take more time than say running it in C, right? So that's the trade-off, right? Each of the language use different tools again, right? The way you manage the memory, the way you manage variables, the way you manage implicit transformation of certain data from integer to say long integer, or how it handle each of the object. These things impact performance, and we haven't really even touched modern day computing where you can have more things than just the CPU. Right? These day and age, you have the GPU on hand in most computer that you can play around with and use it to accelerate program. Anyone heard about the neural processing unit? You heard about iPhone, right? Any people? How many people here have the iPhone? All right, everyone's gone. So basically, inside the iPhone and many modern smartphones has this special hardware that is designed to run machine learning. It's a huge ass uh hardware to do matrix multiply add basically, right? Sometimes they call it neural processing units. Sometimes they call it machine learning accelerators. But these things are actually available, right? Have you ever wondered how do you translate the program that you're writing so that it run over there, right? So these are all the questions that people who do parallel programming languages, people who have to design parallel program, people who have to design the system software have to think about, okay, how do we actually do it? And again, because we want performance. It's because performance is so important to you, to everyone, right? And hopefully this is a good motivation because in Rust, you can write parallel program relatively easily. Let's say I want to parallelize the function that load an image, right, into a vector, which is basically think of it as an array of images. And because this function, I mean, if you think about it, you can load the first image while you're loading a second image, while you're loading a third image. It is going to be done in parallel. And as I highlight here, you can use a parallel iterator to go through the path in parallel. The map function will go into the detail in the, I think in the next slide, actually, not next slide, next lecture, actually, on why are they good for parallelism. But at the end of the day, it actually does provide you this data parallel library to convert sequential program into parallel execution automatically, right? So this is nice, right? So I really recommend you to try this out. Uh, in this particular example, the path is now being iterated through in parallel. So you apply the map function to load an image all in parallel, right? You also can actually use Rust to detect data races. We go through this particular example where you want to count the number of JPEG files, right? And with the highlight part, Rust will yell at you basically that, hey, this cannot be done in parallel because JPEG is a shared variable. If you want to do that in parallel and have two things updating this value at once, you can end up, instead of JPEG equals 2, you end up with JPEG equals 1. The reason behind that is, let's say both of them want to read the value of JPEG, which at the point is 0. You increment 1 to that, you end up with the value 1. The second thread, the second entity that wants to load the image, didn't get to see that update. So that results in the bug, basically, where you have data rest and the final value becomes incorrect because both of the thread or more threads want to access this value at the same time, right? So you can solve this by using atomic instruction or lock this whole part making sure that they cannot be parallel execution on that line. And we talk about atomic operation a little bit, which kind of like we draw a parallel to the I guess the chemistry side of what is atom, right? I mean, these days we know it's not the smallest unit anymore, so it's not true anymore in chemistry. But at the same time, well, we still use the same word. Atomic operation is basically it's a sequence of things that you can do. It can be any operation, but the atomic operation will either all complete or it never happened. You do the whole thing at once. Think of it as a transaction, right? You go to the bank and you perform a single transaction. It means that you withdraw your money. You want to make sure the whole thing complete. The bank update the new balance. You got the money. Otherwise, if somehow you got the money and the bank forgot to update the balance, someone lose that. Someone lose money, right? So atomic operation guarantee that that never happened. And this is useful for the case earlier where you want to update this variable in parallel, right? It would allow the parallel update to make sure it gets the correct value. And to read Rust code, here's the example that we went through last week. This basically performed the function GCD or greatest common denominator of m and n, right? Over here, input variable name mut specify that these are mutable. So this is a good middle ground between Scala and Rust because you can use mutable. The reason why mutable is still not that great to use all the time is it's gonna make your program slower. So minimize the amount of mutable that you want to use. But at this moment, m and n are mutable. The reason why they are mutable is if you look at this line, you see that you have to modify m and modify n. That's why you make them mutable. Assert is a macro. The pound thing is assert only if false. Otherwise, let them proceed, right? Assert basically is a function that would say, it would check, basically it would check the condition that you have in this parenthesis. Okay, that's a question whether it is in sequential style, and the answer is yes. That's a great question. This is done sequentially. So there's nothing here that make things run in parallel. And that's a great question. This is sequentially done. So the macro would check if n is 0 or m is 0 because it means nothing to do a GCD of something that has 0, right? So it would check if m is 0 and n is 0. If none of them are 0, you proceed. Otherwise, the program will stop and yell back at you, whoever run this program, and say, hey, it's not runnable because your input is 0. Parentheses in the condition check is okay. You don't have to put it. You can create local variable by the keyword let, right? Let means that it just, as the word suggests, let t equals m. So I'm gonna make sure I create a new variable called t. I'm gonna assign the value m to t. Type in this case can be inferred, basically it's the same type of m. And then the return is at the last line of that function call. So this is how you can read Rust code, which actually look almost like Scala. You have a function name, you have the, instead of def, you use let, and then for mutable, you just put in the keyword mut. And then everything has a type, everything would follow the type. Basically, it's a strongly typed language still, so it would still maintain the type throughout the full run. And then we talk about generic. What if I want to parameterize a type? Let's say I want to type T, which can be anything. In this case, I want to be an order type, which means that I can compare between A and B, right? Oh, that's a great question. So the question is, do this create pointers or copies? The answer over here is it's create copies, but it depends on the data type. So actually we discuss about it today. We'll discuss about it today because each type that you're dealing with, sometimes it's more like a pointer. Well, Sometimes you do a deep copy, sometimes you don't. And we'll talk about it because that is an overhead of the deep copy, and we'll discuss what does deep copy mean. So table that question for now. We'll talk about it actually in about, I would say 15 minutes. In about 15 minutes, we will actually reach that discussion. For now, if you look at generic, right, it means that you have a data type T, which will, in this case, follow total ordering because you specify it over here in this bracket right here. Then you can do enum to basically construct things like option, right? So you can use enum option of T, where it either can be none or sum of T, right? Or you can do something like save divide. Use the same concept of option that we learned back in the first module, right? When you talk about scalar and functional programming. If d equals 0, I'm going to return none. Otherwise, I'm going to return sum of n over d. And then you can do pattern matching to extract what to do if you have none or sum of something, right? And you can use this to catch error as well. So results of T and E is basically enum of result T and E. T is a type, E is an error, right? So if it's okay, T means the whole thing runs fine, it returns the type T. If it's ERR of E, it means that this thing has an error. Is this whole thing, whatever you want to do, result produce an error. And the error message, basically the error message, it doesn't have to be the text. It can be any type is E. We actually use this to print the content of the directory as an example last week through standard IO error. So I'm not gonna go through that because we're gonna transition into the content, the new content basically. So the other thing that Rust gave you, and that's actually relate so much about Justin's question, whether these create pointers or copies, is memory safety, right? So Rust provides 3 promises about memory. It doesn't really give you pointer, to be honest. So there's no null pointer dereference thing. Forget about segfault. You are not gonna run into that. Yay. So no null value, you use an option or you use results, right? So you option of T and none is a valid alternative to null pointer. No dangling pointer, right? No garbage collector, no pointer that is not being assigned, no buffer overrun. So this is more related to the things that can be done to a program to hack your program. No pointer arithmetic. You can just assign a pointer and add 10 to that. Array in Rust is not a pointer, but in the high level, it behaves like an array as you know it. There's a boundary checking at the compile time. Basically, compiler know exactly where your array ends. There's no weird like dynamic allocation call like malloc in Rust. So that kind of get rid of this memory management where you can run into buggy code and segfault, right? But instead of this weird memory management, we have the weird number 2 memory management, which is called the ownership system. So the ownership system is interesting. And the way I would explain it is it's kind of the same as how you own things in real life, right? So let me ask you this. If you go, let's say you go to a mall and you buy something, who is the owner of that item and how does it transition from one owner to the other owner? All right. Can someone give me an example of things you want to buy? Just anything. All right. Toilet paper. Okay. And also laptop, banana. I like both toilet paper and banana. So let's say I go to a mall and I want TP, right? Before I buy it, who owns that toilet paper? Let's say I go to Lotus to buy toilet paper and banana. Before I buy it, who owned those things? Lotus, right? And let's say I want to buy a laptop with that too, right? Who owns, so let's like a Power Mall in Lotus. So in that case, Power Mall owns the laptop, right? Until you make that purchase, can you do anything to those laptop, banana, and toilet paper? Can you do anything with it? No, right? It's not until you buy those items where you can actually use it, right? You cannot even use it. You can consume the banana only if you bought it. The ownership system in Rust works the same way. It works the same way, right? For another thing that I want to ask you, if I have an item, can I have multiple owner? Like let's say can more than one people own the banana or the toilet paper in real life? So that's a yes and no, right? I guess you can share the money to buy like this whole bunch of banana and you have the joint ownership, right? In Rust, the difference here is the ownership system have one owner. So that's the difference. So the parallel is the ownership system kind of work the same way as real life. So that's why I think the word is perfect, the ownership system. But there should be a single owner. So here's the overview, right? If I say I want a memory to be safe, if I want the memory to be safe, what are the things that can be done to the memory that will make this unsafe? And this is in the context of ownership. So that the hint I'm giving you here is ownership, right? So what can be done to a piece of data that would make the memory not safe anymore? One other thing that can happen is, what if it's co-owned by two entities, right? I have a shared data. I have a shared data, and I want to update the value, right? With the joint ownership, if I have no way to control who gets to modify that value, you can run into problem, right? You can run into problems. Both of them want to modify this value at the same time. Who get to pick who go first, right? So these actually have a lot to do with how you want to share the data, how you want to share the data for parallel updates, right? For parallel updates. When do I need to, well, the other thing I have to consider, right, is when do I need the memory? And when do I free? Right? When do I free? How do I know that hey, no one use it anymore? So with the ownership system, so let's say I have this high level overview of what I just explained about the ownership system. Can I tell when do I no longer need the data? What what does it mean for a piece of data that doesn't have an owner? Yeah, so the question there was a question about this help with data risk. Yes, exactly. The ownership system is one of the things that people invented to kind of like deal with the data risk problem. And we'll tell you in a bit how. The other thing is about, can I know when can I throw away this piece of data, right? When do I free up that memory? Can I free it if the data have no owner? No one owns it anymore. Can I free that piece of data? Yeah, that's gonna like take care of one of the complex questions. Like, can I free that? Can I free that? Well, no one owns it. I'm gonna throw it away, right? So we'll go really minimalism if I have an item in my house and no one owned that item, I'm gonna throw it away. I'll have a clean house, right? Which is totally the opposite of my house right now. But you all agree, right? If we have this ownership system and somehow if I have an object that no one owns, I can throw it away. And Russ basically introduced this ownership system to provide the memory safety, right? So let's look at this first question of the lifetime of a resource, right? Basically, Russ will kind of actively find the lifetime of each resources, right? Remember our old friend scope, lexical scope, dynamic scope, the thing that appeared on the last question in the exam. Remember, and I hope you still remember that, right? So when you check the scope, you know when you no longer need certain thing, right? You know, you can identify that, hey, no one use that function call anymore because in the future no one use it. So by this line afterward, you know that no one need that. There's this thing called also the liveness analysis, which is a compiler technique to kind of go through your code and see which variable is still alive and which data that tie to each of the variable are not alive anymore. So you can use it to also free things up. We'll not talk about how that's done. If you're curious, let me know because it requires about like a lecture worth of like multiple lecture words actually because you need to kind of understand how the compiler work. I will not mind at all to kind of like go through the details here, but only if you want to know about it because we have only a limited amount of free slot for this class. And there's also already some interest into like how do you program in the GPU. So right now that would be the topic I'll try to fill in. And the other thing is, you have to remember that when the lifetime end, resources are being free, right? This is how Rust handle memory management. And here's some example. Let's say I have this bracket that say s equal hello, and you do something with it, right? So when do I know s is a value? At what point s exists? This is line number 1, line number 2, line number 3, and line number 4. Out of these 4 possible lines, where is the existence of S? Number 2, right? That's when you do let S equal hello. And it no longer become valid after line number 4, right? Because you have that curly bracket that tells anything outside of this scope no longer valid, right? So basically, it's not valid anymore. If I call s afterward, the value disappeared. Basically, you cannot refer to that value anymore. Any questions so far? Any questions so far? So this is almost similar to, let's say you write a code in Java, right? And you have a function call, and inside that function call, you have some local variable. That local variable is only accessible within the function and not outside of that function. So similar concept here, right? And the rule for the ownership is this. Every single value will have one single owner at any given time. Why is this good? So this basically will help, basically would help exactly for Manit's question earlier that said this help with data rest, right? That's the answer. It help with data rest. It allows you to tell who gets to modify the data, So let me ask you this question. If I assume that for every single piece of data that can only be one ownership, so how many writer that can update my value at the same time? One. Yeah. So it takes care of data risk, right? I establish if I own this data, I can modify it. If you own that data, you can modify your data. If I do not own the data, I can't modify that, right? Make it really clean. So in that case, it's clean, but it's kind of limited, right? So what can you do? Let's say you are at your friend's house, right? And oh, awesome. So this is basically the leading question. Can you ask the owner to modify it? And I'm also about to give an example of like exactly that, essentially. Let's say you're visiting your friend's house and you found that in the living room there's Nintendo Switch. And what do you do if you want to play games over there with your friends? What's the first thing you have to do as a nice human being, except for load it up and delete autosave files? What should you do? Which don't do that to your friends, folks. So what should you do if you want to play your friend's Nintendo Switch? You ask your friends for the permission, right? You lend that. Your friend can lend the ownership to you, or you can ask that person, can I borrow the Nintendo Switch? Right? This allows a nice permission-based system where you can say every single items in my memory is owned by one entity. Anyone want to use it need to ask the permission to use, right? So anyone can borrow a reference to a value. And the quick thing is, let's say I own the Nintendo Switch, right? Let's say I own a Nintendo Switch, and then I sell that Nintendo Switch to someone else. Can you still borrow that Nintendo Switch after I sold the item? The answer is no, right? You can't just say, hey, I'm still borrowing it. You can't sell that item. You can't outlive that. So the system works in a similar way in the sense that if the owner finish the function call and delete that thing, basically that thing went out of the scope, right? You can't borrow them because they already went out of the scope. Another thing about ownership system is if you want to change the value, you need the exclusive access. The exclusive access. What does exclusive access mean? So what does exclusive access mean in English? Yes, that's an awesome answer to that. So it's a special permission where you are the only one who have access to it. You are the only one who have access to it. And why is this dealing with all this data rest issue? Why does exclusive access help with data rest? Yeah, because you guarantee. Basically, you give that guarantee that there's only one single entity who can modify any value at any given time, which means that you're not going to run into data rest. It's a really, really strong, uh, uh, a strong guarantee. You can't have anyone else modifying this. So this is nice, right? And if you program in pthread, which is a parallel thread available in C, right? That's like a POSIX thread where you can spawn a thread, use a thread to run certain things in the background and make sure things can be done in parallel. These share data is like one of the most annoying thing that you have to figure out and make sure there's no bug. But with Rust, it take care of that. It make your life a lot easier, right? Because only you can have it. So let's go through some example, right? If you have a variable, the value that ties to the variable will be basically they have to have single ownership. If you have a struct, each of the field should have single ownership. Allocated value on the heap, right? Let's say you have a new pointer, right? What I guess a concept of pointer, like a new variable that you define, right? You have to have the ownership for that particular pointer on the heap. And if the owner dropped the value, if I own this value and I no longer need it, the whole thing is dropped. It's guaranteed that Rust would come and take care of freeing that part, right? It would free that. So let's go through some of the possible, I guess, types that we're gonna use to address Justin's way earlier questions about deep copy, or do you give the copy versus giving the pointer, right? So in some cases you're giving the copy, in some cases you're giving the pointer. So let's talk about the string, which is one of the most basic thing where it's not as simple as like integer. Integer is only have one single number and you're done. With a string is what? What is a string? What does what is the basic data type within a string? It's a bunch of character. It's a sequence of character. So there are two ways to, well, my bad, grammar mistakes. Two ways to represent a string. The ampersand string, think of ampersand as like almost like a pointer, right? So if you come from the C side of thing, yeah, you see that and say, okay, it's a string. Or the object string, right? So what I can do, let's say I said let mutable s equal string : from hello, which basically means that over here the hello is a primitive string. The primitive string is this ampersand string. And then this whole thing, if you program in Java, and you write something close to this string : from hello, what's the type of s? What's the type of this variable s here? Is it an object or is it a primitive? It's an object, right? So this becomes the object string. So instead of a literal, it becomes an object, right? So if I say s dot push string world, right? This means that push string would append this literal to our string and print line bang up. So basically this is how you print things. Print line in the bracket is whatever goes into there. With this bracket, you look into the next argument, which is s. So you print hello world. Basically, this will print hello world. The bracket specify that this is something I want to print. The value look into that input. The value looks into the input. So that's a question about what's literal. What does literal mean? It kind of, so I kind of want to draw the meaning from the English meaning of literal, right? It basically specify the actual data. I'm not sure if that's the best explanation for literal. Uh, I believe you can also just do print line s, but I'm not 100% sure, so let me double check that after class. But with literal, it's basically whatever data that are being presented here in the quote, like in this case is a string literal. It means like hello or world, like whatever you give them the data, but it's not tied to any fancy things that a class is able to do, right? Because it's not a string class. So you can't just say quotation hello with the dot push string. You have to first convert to a string type, and then you do the push string because there's no function tied to it. In this case, literal is just literally data. No additional built-in function and features that come with the class. So hopefully that answered the question. Yeah. So with this particular pushing string, right? Let's look into what will happen if I need to copy certain data, right? So I say f and main. This is basically the main function. Inside the bracket, you say x equal 5, y equal x. So this, what does it do? It basically bind 5 to x and copy x to y. What if I do this? What if I do this? I have s1 to be the string hello, and I say let s2 equals s1. Let s2 equals s1. Remember with integer, you do a copy, right? How complex is a copy operation if we have an integer? So I need help from folk who take system skill before. If I have to convert this copy operation to assembly, what does that translate to? Anyone still remember assembly? You remember this instruction? Basically, this is one instruction in assembly, right? So it's fast. So my key here is it's really fast to copy one integer value into another integer value. What about a string, right? In a string, what will happen here is it will say user move value as 1. And with this, what will happen here is when you say S2 equal S1, it's not being copied. It's not being copied. So there's only one object that has hello in it. So if there's only one object with the word hello in it, how many owners can I have? How many owners can I have to this string hello? One, right? Over here, there's one owner. But over here, when you do the copy, it's actually two different data. So if I have two different data, how many owners can I have? For each of the data, you can have only up to one owner. But you can, because there are two pieces of data, there can be two owners, right? The reason behind this is with the string type, it's not implemented, right? It's not implemented. Because to copy a string, what do you have to do? What do you have to do? So what are the basic operations that you have to do if you need to do a string copy? If you have to write your own function string copy, what you ended up have to do? you have to basically loop and copy each character at the time, right? So basically each character has to be copied individually. This is called deep copy, and this is basically costly. It actually takes, if you have to loop and copy each character at a time, it consists of many instructions, right? So that's why we call it deep copy, and by default, many objects in Rust will not have that property. So when you do S2 equal S1, one ownership. So one thing you can do, let's say I want to make sure S2 is its own object. You can clone them, right? So if you know that, hey, I need a deep copy, I need another separate copy of that data, use clone. So this is what you can do, s1.clone. So instead of S2 equal S1, which basically make sure that S2 and S1 point to the same object. In this case, you have two separate objects, right? Two separate objects. Is it clear on the difference between the S2 equal S1 for the string versus S2 equal S1.clone? Now you have two pieces of data. You can have two owners. S2 can modify its own data. S1 can also modify its own data. It's fine. Earlier example, you cannot really modify S2 because S1 still owns that string. You need to somehow give that ownership. And these are types that have the copy trait, which basically means that if you do x equal y, it would do the copy. And guess what? Anything that's a basic integer type, boolean, floating point, character, or tuple, where everything inside is a copy type, right? Why is that the case? Well, it's simple. Because copying these small piece of information is simple, right? It's not costly. So by default, you're gonna get a copy. Oops, my bad. Duplicate slides. And let's take this concept of ownership and think about how you can call a function, right? How you can call a function. Because when you call a function, what do you have to do? You pass the value, right? You pass the value into the function call. So consider copy was moved from the example, which I'm gonna show here. So let me get through the example a little bit. Give me 30 seconds to browse through my computer and open it up. I'm gonna upload the example after the class. Here is a, can you see my screen? Hello. Can you see the code? And is the font size big enough? Let me make it bigger because I have room. All right, is it good enough? Okay, so what does the function do? So let's look at the main function first because that's where you will do most of the function call from. There's a function main. Start with I'm gonna create a string that say hello, right? I'm gonna call a function that say take ownership, and then I'm gonna do make copy. Let's look at what does each of the function do. Take ownership basically will take the ownership of S and print some string. Then function make copy will basically make its own copy and print that integer, right? The comment to the right explain what each of the line have to do regarding the scope of S, which is our string here, and X. I think this is a bad letter to use because S and X doesn't sound that much different from me, who is not using English as the first language when I was born. So S is a string, X is the integer, right? And note from our lecture, you realize, right? If you use S, you cannot do the deep copy. What does this? Okay, that's a question of what does this do? This thing, right? This thing basically specified that I want to print whatever's in this quotation mark, but whenever I see this bracket, go look at the argument. That's the value I want to print. Basically, it allows you to print variable. Same here. Look at the value. I'm going to print some integer as a value inside this curly bracket. All right. And because S without the deep copy, right, over here, how many ownership can S have? Let me ask you this. How many ownership can S have? One, right? So let's go through this particular example. Right now, S, what is the scope of S? Basically, the ownership of S here, before I call the function main has it, right? The value S, not the value, the variable S owns that, right? This is line number 3. The variable S owns the value of S. All right, with me so far, I'm gonna go into line number 14, which is this function call, right? This function call. So in this function call, what's the input variable? What does it call? It's called some string, right? Some string. What's the value of some string? What's the value of some string? I mean, you look at the code, what's the input? Hello, right? So the value is hello, and the only thing I do is print hello, right? So on your screen, you should have the word hello. Nothing much that special that happened, but in terms of scoping, over here, some string come into the scope. When you are at this line, the end bracket, what happened? What happened? When you are having that exit bracket, right? It basically means that the hello go out of the scope, right? Because I finished the function call. Hello go out of the scope. Because you're not making a copy, you just pass the ownership to this function call. What happened here? Data is thrown away. Awesome, that's the right answer. Basically, this data hello is thrown away, right? So what if I want to modify this and say print, my bad, let me type here. So what will happen here if I do this? It's gonna yell at you. Yes, it will not compile because from the point of view of Rust compiler, you're not supposed to take and use S anymore after that point because S the scope of S is still here, but the data is already thrown away earlier. So no one owns that data anymore. You can't use it, right? You can't use it. So this is how you can take an ownership, and we'll explain how we can fix this problem if you want to use S afterward. We'll talk about how to do that. And that has to do with borrowing and lending. It has to do with borrowing and lending, but we will talk about this now. This particular example for now. So you cannot use S afterward. How about this? Will you make a copy X here? Because X is a copy, does the ownership of X the same as the ownership of some integer here? It's two copy now. It's the data 5, both copy has the same data, 5 and 5. Over here, in the function make copy, some integer is its own copy of the value 5. So it would print 5, it would get rid of 5, right? But can I basically do this? Can I say, I hit Notepad++, with just auto indentation. Is it valid? Will it compile? Will I get into any error? Yeah, it will compile. It should compile actually, because when you make a copy, no one touch X, right? X is still there. It go out of the scope only at this line, right? So that's fine. I can do it because because actually it's not exactly because X is a primitive, but because X has a deep copy by default. So when you call this function, you create another copy of X, it get used, it get destroyed, but once you return that function, X is still there because you destroyed the other copy. And that's the key, right? And that's the key. So with this example, basically, hopefully this give you some more insight into how you can run into compilation error that are related to the ownership system in Rust, and think about who owns what at what time. Because if you want to modify certain things and you don't have the ownership, you cannot really modify it, right? This is the same thing that happened with the S earlier. For this particular example, I said let name equal format something dot dot dot. Is just a way you can create a string, right? And say I want to have a helper function that say take an input string and print it. This is going to be okay because I give the variable name, whatever data in there go into the helper and you get print. But this is not okay because by that time name is the data already got thrown away right here, right? Same exact reason. This is actually the same exact example I showed earlier. So this is kind of funny. So let's talk about how to actually pass data around, right? It can be useless if you pass the data in a function. The next time it comes back, the data is gone, right? This is going to be useless, and that's something we need to fix. So let's talk about how to move the data, how to clone the data, and how to copy the data. Moving the data is basically when you pass the variable that cannot be copied around, like that string. Right? You move the data into, you move the ownership there. Once the function finished, you eliminate that object. If you want to make a copy, clone it first. Clone it first. Either clone it first or lend the ownership into the function call, which we'll talk about it in a bit. When I said copy, it basically means this is implicitly done, like x equal y, and x is an integer. In that case, y is another separate copy because it's implicitly done. You have x and you have y. Now let's talk about how to fix it. It's called borrowing. And this is a nice concept because what does borrowing do? What does borrowing do in real life? Let's say you borrow your friend Nintendo Switch. What does it really mean? Yeah, you temporarily take it, right? It basically means that you temporarily transfer the right to use. You give them the right to use to someone. So if you look at the code, you might see this ampersand, right? Ampersand basically means that that thing is borrow. That thing is borrow. For example, remember our helper thing that break the ownership rule, where you have the helper function, print the string, and you finish with that. One thing you can do is first make sure I have the variable R that borrow the ownership of name. It borrowed the ownership of name. And then I pass R in as an input. And then over here, the input also borrow, right? It borrow the ownership of name. Basically, it's borrow that to make sure when I finish the function call, I don't destroy the data, right? You borrow it to make sure you can return it back, right? If you borrow your friend's Nintendo Switch and when you're done using, you destroy that Nintendo Switch, what will your friend do to you? Yeah, you're a nice guy. You said forgive, and you're gonna play Smash Bros in real life, right? You're gonna probably smack your friend a little bit. Yeah, so that's not nice. Borrowing, when you borrow someone, at the end of the day, you're gonna return the ownership back. And the same goes with this example. When you finish with the function call, right? When you finish with the function call, you return the ownership back to whoever owns it. Borrow is immutable. When you borrow something, you cannot modify anything with it, right? This is a little bit different with the Nintendo Switch analogy because when you borrow, you can probably save the game on top of your friend's save game and do those kind of things, right? But in Rust, when you borrow something, you cannot write to it. So, for example, this is okay. I just print the name. But this is not okay. This is not okay. I borrow a string and I want to put X at the end, right? I want to put X at the end. This is sneaky. Basically, you borrow someone's item and you modify it, right? Not okay. Not okay unless you declare that you're gonna modify it. Not okay unless you declare when you borrow that thing, tell your friend, hey, I'm gonna use that and modify that. I'm gonna borrow that banana and I'm gonna eat it. And I'm gonna give back the remaining banana. Right? I'm not gonna talk about toilet paper example because it's kind of gross if you borrow and use it. So let's stick with banana example. This is called a shared reference. Right? So you share the reference, it becomes immutable. You can read, but you cannot write. So instead of borrowing, what's the same thing, but start by the owner giving you the ownership. That's called lending, right? Lending is basically when the owner gives the permission to someone else, right? So the difference in the code here, this thing is the same. This thing looks the same, right? You are going to borrow name. Instead of having the separate variable called R, borrowing the name, over here name said, hey, I'm gonna hand off this part to helper. So I'm gonna say ampersand name. Ampersand name means that this function call, I'm gonna lend this particular variable and data to the helper function here that I call. I'm gonna lend the ownership. I'm gonna lend the ownership. If you do this, it's a part of the string. If this is basically the entire string. So you can lend a part of your data. You can lend the entire data, right? This is another way you can borrow, basically. But instead of borrowing from the borrower, you have the owner giving the permission. So anyone wonder, so what if I want to modify the data? Right? In most cases right now, when we borrow and when we lending things, you cannot modify the data. But what if I have a function that need to modify the data? I mean, those functions exist, right? I want to modify the string that I borrow. This is called mutable borrowing. By putting the keyword MUT, by putting the word MUT, you can now modify the data, right? So this is one example. Let mutable name, so now name can be modified. It's not immutable anymore. And you call the function called update. Ampersand MUT means that I'm gonna lend name to the update function, and I'm gonna allow the update function to modify this. Then inside the function update, you say ampersand MUT again to tell the compiler that string called name here can be modified. So now you can basically modify the string, right? So with this, we can kind of categorize the types of ownership into various types, right? If you are the owner, you have the full control. Free when done, right? This is clear. After I'm done using this particular data, it gets free. I'm the full owner. I have full control over this piece of data. Shared reference means that I have many reader, no one writes to it. No one writes to it. Something like ampersand string, I am going to lend this, I'm going to borrow this. So if I can guarantee no one is going to write to the data, why is that good? Why is that good for performance? And this is in the context of parallel programming. Why is it good that I can guarantee no one will modify that piece of data? So what if you have data rest? What if you have data rest? Will it be buggy? Will you ever get into any buggy situation if you have data rest? So let me go back one step, right? When I see data rest and it kind of bugged your program, it usually it happened when, right? I'm reading the data and someone modified it in the middle of reading. Someone modified my data while I'm reading it. Will that case happen here? Will it ever be the case that someone, yeah, no, by default, right? Share reference, there's no writer. So I guarantee if I look that data up, That's the data. There's no way someone can modify the data. That means I can have as many reader and read that at the same time, and I guarantee my program will behave the same way, right? So this is nice. This is actually really, really, really convenient to parallelize this fraction of your code. So if you have full ownership or a shared reference, you can run things in parallel. Like shared reference is good. Basically, shared reference is good for performance. Many core CPU core, the threads inside the OS can look at that data, do parallel processing, and have a really high performance program, and you won't run into problems. Mutable reference is no other reader, one writer, right? When you use mutable, and this is actually why I want you to practice coding without mutability, right? So if you know that someone might modify the data, what happened? Can you allow them to run in parallel? If you force the string to be mutable, can I have another processor modifying that or reading it? And the answer is no. Essentially, you can only have one single thing running, right? So this creates what we call serialization. Serialization is when you cannot parallelize your program. So that's why I've been trying to tell you, if you say, hey, can I use mutable? I say, try to limit the use of mutable, because if you want a fast program, immutability is your friend in Rust, right? In Rust, immutability is your friend. In Scala, immutability is your friend. In C and C++, immutability is your friend for for the case that you don't want to run into bugs. It helps quite a lot, right? And the next thing that Rust did was it handled dangling pointers, right? And this is done when you in the compile time you know exactly who reads and who writes things, right? So when you have a shared reference, to X, right, it apply what we call a read lock to X. Everyone can read. Everyone can read. Read locks means that I can read from it. No one can write to it. And the lock lasts until this reference become out of the scope. Basically, when I don't need it anymore. Read locks are good. Read logs are good for performance. People can look to that data. People can use the data. People cannot modify the data. So it means that you can do this in parallel. Mutable reference to X, it apply what we call write locks. Write locks means that no one else can read from it, and only one writer. And the lock lasts until it go out of the scope. Basically, you can't really, right? You can't really have parallelisms when you apply the right locks. All right, so let's look at this one example. Fix the code. Anyone want to take a stab? Let's actually stare at this code for like maybe 2 to 3 minutes and see what's wrong with it, with the ownership system. And I guess hint is on this 2 line. So can someone tell me what's wrong with the code? And let me talk about this part. Is this a read lock or write lock? Is that a read lock or write lock? Yes, and you are correct. This is a read lock. Right? You're applying a read lock. What did you do here? What do you do to buffer? You modify it, right? So over here, you are writing. So how do you fix it? Do you apply a read lock? So you need this. Yeah. No, it's actually ampersand mute because you did basically make sure, right? Make sure you can modify this. All right. So how about this? What's wrong here? To be honest, it's kind of the same thing. Even though you try to like put this into different sizes, you want to make sure you apply the correct lock, right? You apply the correct lock. Again, this is a read lock. You want to modify it, right? So that's what's wrong here, right? All right, so that's it about the ownership system. The next thing I want to talk about is the try macro, right? This is kind of like I would say try catch, right? If you look at this code, it's kind of annoying. The reason why is I want to do some calculation. The calculation return results with either a value or a string that has the error message, right? But this calculation consists of multiple sub-calculation, right? Multiple sub-calculation. And at the end of the day, I just want to do a plus b, right? A plus b. And with this, it's kind of annoying because every time I have the sub-calculation, I need to have my own error message value that I'm going to return and all this pattern matching. So the try macro allow you to do something like this. Oops, my bad. This should be B. Let B equal this pattern matching, right? So the try macro allow you to do this. Do calculation, will return results. A, try to do subcalculation. B, try to do subcalculation. The error is implicitly return when you return OK A plus B, right? This is similar to the try catch, basically. This is basically similar to try catch. And I think that's kind of basically cover everything that we want you to cover for the basic Rust, right? The next step is, I think, is a great example here because we have in class exercise 11 that has the code that doesn't compile. Make sure you go look at the code and modify it so that they compile. That's your in-class exercise 11. We are switching the language from Scala to Rust. So I want you to be familiar with the language a little bit, with also the borrowing, lending, ownership system. So go look at the code and make sure they compile. Modify it so that they compile. Assignment 2, as I said, something I want to bring up is the due date, my fault, is right before the midterm. So as same as assignment 1, I'm going to extend it by a week. But if you submit on time, which is last Monday, you get 10% bonus to your total grade. So you do the calculation, whether you want to keep it or work on the remaining problems. All right. And one more thing that we have is, let me bring it up actually. So if you look at Canvas, so if you log in through Canvas and go to the class, you will see that I have a new assignment called Project Proposal here. Is due on June 29th, which is not next week, but the Tuesday the week after, right? Tuesday the week after. And I don't want much here. The only two things that I really would like to check is what's your what's your project, or give me the summary or a brief description of what do you want to do for a project. And the other thing is, what's your 100% goal? What is your plan if you are not able to reach that 100% goal? What's the 75%, 100%, and 150% goal, right? So that's it for the proposal. Basically, it's worth 10% of your project grade. It allows me to keep track of what you want to achieve. So for those of you who talked to me already, it's pretty clear on what you can put in. You can say, I want to work on X and Y and Z, and here's my goals for 75%, 100%, 150%. The reason why I need this percentage goal is so that I can take a look at it. If it's way too hard, I will adjust that. If it's way too easy, I will also adjust it, right? So to make sure the project is the right difficulty for everyone. And now that we are about 1.5 hour into the lecture, that's it for the lecture part of it. Now I think it's a great time to brainstorm over the project. So I'm gonna switch over to Discord. I'll be online. I will basically take questions. Let's focus on the project and the in-class exercise 11 first. Don't worry about the question. If you have question from the midterm, we will go over that next Tuesday. We'll go over that next Tuesday. For now, let's think about what you want to do for the project. So let's brainstorm. You can ask me, what did students in the previous semester do? What can you do? Do you want to try to play with certain things? I will see if I have a resource for that, so you can try and play around with it. All right. So let me stop the recording.